The AC motor is a common source of electrical rotary power. Most AC motors do not use commutator or brushes, which makes them more reliable and less expensive than DC motors. The primary use of AC motors is for constant speed applications because the speed of an AC motor is dependent on the line frequency. AC power is supplied in two forms, single-phase and three-phase. Single-phase AC is a common form supplied to homes and businesses and requires two wires. Three-phase power is usually only available in industrial locations and consists of three separate 60 Hz sine waves, 120 degrees apart, on three wires, or four if you include the neutral. The most common type of AC motor is the induction motor. In the induction motor, power is supplied only to the stator windings, where it creates a rotating magnetic field around the rotor. The rotor receives some electric power through induction from the stator, which it uses to generate a magnetic field. This field is attracted to the stator's rotating field, which causes the rotor to rotate, but slightly slower than the rotating field. Motors are designed to run on either three-phase power or single-phase power. Three-phase motors are the simplest because they are self-starting, but they can only be used where three-phase power is available. Single-phase motors are not inherently self-starting. There are a number of ways used to start single-phase motors, and most involve adding a second set of stator windings, called a split-phase motor, which are only energized during startup. The synchronous motor is designed to rotate at an exact multiple of the line frequency. For larger motors, this means that the rotor receives its power through slip rings and brushes, which complicate the design. Induction will not work in this application. Smaller synchronous motors, timing motors, do not use slip rings. The universal motor is so named because it can run on AC or DC. It is essentially a DC motor with brushes designed to minimize the losses that occur when running on AC. AC motors have a large initial current when first switched on. For larger motors, a special starting circuit may be required to prevent damage to the power system and/or the motor. It works by reducing the voltage to the motor during startup, either by resistors or transformers. The speed of an AC motor can be controlled in two ways. A small amount of speed control can be had from simply reducing the voltage, which causes the rotor speed to slip more. For complete speed control, the frequency must be controlled with control circuits that convert 60 Hz AC to other frequencies. The simplest of these systems is called a variable frequency, or volts per Hertz drive. Better motor performance is possible with newer, more sophisticated units called vector drives. This brings us to the end of our section on AC motors and the control thereof.